In today's lesson, we're going to learn some of our elementary differentiation rules. So far, we have been taking the derivative using the formula f prime equals the limit as h approaches 0 of f of x plus h minus f of x divided by h. This is known as the definition of a derivative. We can find the derivative of any function using this formula. However, to compute a derivative using this formula is a very time-consuming procedure. So mathematicians have come up with some shortcut rules to help us calculate derivatives. The first rule is the constant rule. The constant rule says if I take the derivative of a constant, it is 0. And if we look at the graph of a constant, so if I was to draw the graph y equals 7, which is just a horizontal line, derivative represents the slope of a tangent line. Well, if I was to take the slope of the tangent line anywhere on this horizontal line, the slope would be 0. So that is why the derivative of a constant is equal to 0. So if we look at a few examples, f of x is equal to -7. I'm asked to compute the derivative, which is f prime of x. So therefore, f prime of x would equal 0. Similarly, f of x is equal to pi. Pi is a constant, therefore the derivative would be equal to 0. So anytime we're given a constant to take the derivative of a constant is 0. Now our power rule. Our power rule says if n, which is my exponent, is any real number, then a variable raised to a power n, if I was to take the derivative, I simply bring my exponent out front and I subtract 1 from my exponent. Let's take a look at a few examples. If I'm given the function f of x equals x to the 7th, to find the derivative, all I do is bring the 7 out front and subtract 1 from the exponent. So f prime of x would be equal to 7x to the 6th. If I was given y equals x to the 100th, my derivative would be y prime is equal to 100 x raised to the 99. This notation is known as Leibniz notation, and this right here means I'm taking the derivative of my function in terms of that variable, which is u. And if you notice, my function is defined in terms of u. It is u to the 9th. So to take the derivative, I use the power rule. The 9 comes out front, and I subtract 1 from the exponent, so my derivative would be 9u to the 8th. If I'm given a function that is a radical, first thing I need to do is get it in a derivative-friendly form, and that would be to rewrite my radical as a fraction. So that would be x to the 1/2. Now, when I take the derivative, I use the power rule. Oops, let me just undo that a little bit there. Okay, we'll try that again. So f prime of x equals, the 1/2 comes out front, subtract 1 from my exponent, and it is x to the -1/2. Now some textbooks do not like to write their exponents as negative, so they would rewrite it as 1 over 2, and they'd move the x down to the denominator to look like that. And some textbooks might even go further and rewrite it like that. So that would be the derivative of the square root of x. If I was given something like x raised to the 5/6, to take the derivative, again the 5/6 comes out front. 5/6 subtract 1 is going to be -1/6, and that would be your final answer. Again, there are many different forms of writing the final answer, but we'll just leave it like that for now. If we have something like 1 over the cube root of x squared, again, the first thing I need to do is write it in a derivative-friendly form. So again, the first thing I'm going to do is rewrite the cube root. I'm going to rewrite the cube root of x squared as a fractional exponent. So that would be x raised to the 2/3. And then I'm going to move that 2/3 up to the top to become -2/3. Now I have it in a derivative-friendly fashion, so I'm going to be working with this form right here. Now to take the derivative, f prime, I bring the negative 2/3 out front, and I subtract 1 from the exponent, so negative 2/3 minus 1 is going to be negative 5/3. And that would be your final answer. All right. Now, if you recall back to some of the questions in sections 4.3 and 4.4, we were asked to find the equation of a tangent line. To find the equation of a tangent line, you need two things. You need the slope, and you need a point. Okay, well, for this particular question, we are given the point. The point is negative 2 and 64. And we're asked to find the equation of the tangent line to the curve where y equals x to the 6th at the point negative 2, 64. So the first thing I need to do is I need to find the slope. Well, to find the slope, I have to take the derivative, because the derivative represents the slope at any point. Let me just clean this up here. So y prime is going to be the derivative of x to the 6th would be 6x raised to the 5th. So now I'm going to find the derivative evaluated at the point where x is negative 2. So if I plug negative 2 into the derivative, I get negative 2 raised to the 5th power. I apologize, this pen is lagging behind on me. So this is going to be 6 times negative 32, because negative 2 to the 5th power is negative 32. And if I multiply that together, I get negative 192. So that is my slope. So now I have the slope. Okay, so that's going to be important to me. I need the slope. I have my point, and now I can find the equation of the tangent line. And to find the equation of a tangent line, we will use, got to clean that out there, sorry, back to my pen. We will use the equation y subtract y1 equals m times x subtract x1. Let's get a new page here. So now it's going to be, well, if I look back at my point, it is 64. So it's going to be y minus 64 is equal to, my slope was negative 192. So it's negative 192 times x minus my x coordinate, which was negative 2, which will make that plus 2. Now, if I want to clean this up a little bit, there's different ways I could write my final answer. First thing I'm going to do is I'm going to distribute my negative 192 to get negative 192x minus, this is going to be 384. And now I'm going to add the 64 to the other side to get negative 192x minus 320. And this would be the equation of my tangent line at the point negative 2, 64. As you can see, this process is a lot easier than it was in the previous section where we had to use that long limit formula. Now, our next rule is the constant multiple rule, which is very similar to the power rule. And all it says is if I have a constant out front, I just take the derivative and then I multiply my derivative by my initial constant. Taking a look at an example, if we have our function is 10x to the 4th, to find the derivative, it's going to be, well, I bring the 4 out front just like before, but I have a coefficient of 10, so 4 times 10 is going to be 40. And then I subtract 1 from my exponent to get x cubed. So that would be my final answer. If I have something like negative 2 over x to the 8th, first thing, I need to rewrite this in a derivative-friendly form. So I'm going to bring the 8 up to the top, and now I take the derivative. So f prime of x is going to be positive 16, x raised to the negative 9. And that would be my final answer. For 4 root x, no different than before. First thing first, I need to rewrite my radical as a fractional exponent. And now to take the derivative, it's going to be a 1/2 comes out front. So I'll show you all the steps here. So it's going to be 4 times 1/2. and then I subtract 1 from the exponent to get negative 1/2. Now, to simplify this a little bit, 4 times 1/2 is 2, and I have x raised to the negative 1/2. This question here is a little bit trickier, and this goes back to our rule that if we have two numbers being multiplied under a radical, okay, that is going to equal, let's clear that up a little bit here. This is really the square root of a times the square root of b. As long as our indexes are the same, I can multiply radicals. So I'm going to break this guy up. This one is a cube root. So first of all, I'm going to break this up and make this the cube root of 2 times the cube root of x squared. Now, it's only the term that has the variable in it that I have to concern myself in regards to writing as a fractional exponent. The number cube root 2 is just a coefficient. And now I'm going to change this to become x raised to the 2/3. So this expression right here is the same thing as that expression right there, just written in a different form. Now I have it in a derivative friendly form. So to take the derivative, okay, to take the derivative, f prime, 3, or the cube root of 2 is a coefficient, it stays out front. So now to take the derivative of x to the 2/3, I bring the 2/3 out front, and I subtract 1 from the exponent. And now I'm just going to multiply my coefficients together. The cube root of 2 times 2 would be 2 cube roots of 2 over 3 times x to the negative 1/3. And that would be my final answer. Okay, let's take a look at one more. If I'm given f of x equals 3x squared all squared, well, the first thing I need to do right now is I need to simplify this. So I'm going to square my 3 to get 9. And I'm going to square my x squared to get x to the 4th. And now we're right back to what we did earlier. To take the derivative, I bring the 4 out front. 4 times 9 is 36. Subtract 1 from my exponent, which would be x cubed, and there would be my final answer. All right, that concludes our lesson for 4.5 using just the constant power rule and the constant multiple rule. Okay, so there's an assignment for you. I have worked out the solutions, which I'll post on my webpage. So after you watch the video, give these questions a try and check the answer key for your reference.